That's right. We're studying AS level computer science and we're starting data types and structures too. In this class, we'll be looking at the agenda, which is implementing bubble sort in Python. Now, the main goal is also to look at another data structure, which is going to be, I'll show you the book. We'll be looking at things like linked list, stacks and queues, queues first, and then stacks. Okay, these are other data structures. Now, when you look at a linked list, you should know how to add a node, how to delete a node, how to add an item from a queue, how to remove an item from the queue or a stack as well. So those are some things. How do you store information into these data structures? Because what is a data structure? It's something which is supposed to hold data, right? It stores information. So you need to access that information as well, and then perhaps do some manipulation on the data, such as sorting, right? The most basic one is bubble sort. Let's start with that. 1 second, I'll open your book first. One second. Okay, let's see. Now, did you get anything done? How much did you complete?
I'd created a list of numbers.
Okay, list of
I
numbers.
created a temporary variable which I assigned to 0, and after that I created like the maximum number, so the index, which was 7 in this case. Then I created an index equals max number minus 1.
Okay, all right.
And yeah, that's it. That now I was starting to like think how it should go. That I didn't know how to do.
Fine, all right. So 1 second. Okay, can you see the diagram on the screen?
No.
No, not the diagram, right? It's loading. Now can you see it?
Yes.
Now the question was about bubble sorting. It was a past year question, right? I'll show that to you as well. Wait. Yeah, okay. We'll start by doing one passive question, okay? And it will help you first understand what happens in the bubble sort, and then how do we implement it? Question
Okay.
1, skill check. Read the question.
Complete the pseudocode algorithm for a bubble sort.
Okay, so you start with the max index. Okay, it's kind of blurry. 1 second. Yep. So first you have the max index, right?
Yeah.
And then you have something about number of items, okay? For outer 1 to dash, then for inner 1 to something, right? If this is more than something, then you do something and end if, right? You start with number of items. Okay. Number of items will be 20 in the beginning. That's the max index as well.
Mhm.
That won't be 20 actually. We reduced it. It would be 19. Okay. 19. One less than the max index. So we go from 1 to 19, 1 to number of items. Okay. So we know 1 to number of items. Okay. Now, if the item in here is greater than item list. Now look, there's a list of items. Let's just make a list of items quickly. So you can visualize it as well. 3, 4, 5, let's say 6, total of 7 items. Okay.
Okay.
Now, number of the max index is 20 right now. Okay, let's just assume this is 20. Max is 20, right? So this item will go from number 5. Yeah, it's going to go from 1, which is here, okay, till the second last item. As in, we don't have to, check here because I can't do any swap here, right? There's nothing,
Yeah.
there's no 21. So I only check till 19 and where I swapped with 20, right?
Yeah.
Now, so that's where I check until it's 19. Now from 1 to number of items, okay. Okay, so 1 to number of items. Yes, that's what I do. Okay. Now I see this is the item list, all right? The item list is this thing, the list itself, item list. Now, when I have two numbers here, let's say 10 and 20, fine? It's in ascending order. That's what we need to do. So let's just change it, perhaps, get a different example. Let's say this is 10 and 9. Now, since it has to be in ascending order, obviously we need to swap it, right? This has to be swapped. So what I check is if the first item is bigger than the second item, and the second item would be accessed by the inner, whatever the inner the position is right now, plus 1. Okay?
Okay.
So then I take the temporary variable. So either one of these will go into the temporary variable. Your choice. So I'm going to take, let's say, the inner into the temporary variable. No, yeah, okay. Because actually, as you can see, the inner variable or the first variable is being changed first, right?
Mm-hmm.
So I will take this guy into the temporary variable because the inner +1 is changed after that. Does that make sense?
Not exactly.
Not exactly. Okay. So imagine this. This is the inner, right?
Mm-hmm.
Inner is not a good variable name. That's not how you should name it. That's not how you should name it. But for now, let's just see it's the inner index, perhaps. It's called the index. Okay. Index is the position. Now, the inner position or the inner index versus inner index +1. Okay. These are two positions.
Yeah.
These are two positions. Okay. Okay. Did you have computer science class today, Shub?
Sorry?
Did you have computer science class today?
Yeah.
Is the syllabus, is the timing changed?
Yeah, from now on it will change. I move from Friday to Wednesday, I think.
I see. So I was not aware of this. We'll follow that timing from next week, right?
Yeah,
Okay.
that's I think Miss Atika told me to, but this week I'll have to join. So yeah, that's fine.
Okay, fine. Right. So you have inner and then the inner +1. Okay. Now imagine if I have to take something in the temporary variable, right? Now, how do I
Okay.
decide which guy to take into the temporary variable? If I take, let's say, let's put 9 there. Okay, I took 9 here into the temporary variable. Okay, now
Mhm.
I'm putting 9 into 10. So the guy who's being changed first is 10, right? 10
Yes.
changes first. So now this is also 10. And this is also 9. Now everything is 9. There's
Oh, okay.
no trace of 10, right? So since you were changing the 10 value first, you should have taken 10 into the temporary variable.
Okay.
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 So now 9 goes here. Okay. But so both of them are 9 now. So you take this guy to the other variable to swap it. Does that make sense?
Yes.
So now they've swapped. If you put 9 there, then everything is 9 and there's no point.
Okay.
Okay. Now
Yeah.
let's look here. So therefore, since you're changing the inner first, that's the first thing being swapped. I'll put that guy into the temporary variable, and then inner +1 will go into the inner, the previous number, and then your temporary variable will go into the inner +1. Okay, swapped them.
Okay.
Now that's done. Now what you do is you decrement the number of items, right?
Okay.
Bubble sort works in a way to uh, basically sync bigger numbers. Okay, so when you make one pass, the biggest number will definitely go to the last position, no matter what. It will. Now, this one pass means you swap the whole thing. Now you check one more time with 2 and 3, then with 4 and 3 and 4, then 4 and 5, and so
Mhm.
on until the last position. The biggest number will definitely come here. So 20 will be done, okay, in the first position. As in,
Okay.
not 20, but 19 will be done. It's 19 in is the last one, right?
Yeah.
That's where we make the last one. 19 is done, okay? So next time, or actually 20 is done, but next time I have to check from 18, right? Since 20 is done,
Yeah.
so the last swap won't be at 19, it would be at 18. Then after that pass, 19 will be done, then I only have to check till 18, then so on, 17, 16, 15, right?
Yeah.
Okay. So this is the inner loop, the inner for loop, right? Which runs till 19. Now the second pass will decrement. It will only run till 18. So I have to reduce it.
Number item -1.
Number item minus 1, yes. Okay, that's it.
Okay.
Now here you put 19 yourself, right? But usually that's not a good habit. That's not a good habit or etiquette, because you
No,
need
yeah,
to
I'll
change.
-1, yeah.
What should you do then instead of
Max.
19? Yeah, max index minus 1. Okay,
Yeah.
that's it. So that's how you do it. That's the pseudocode and that stuff. Yeah. Moving onwards,
Okay.
you need to do a few more things in this question. A few basic theory on it, and then we'll implement it. Let's see. Why is it inefficient? We haven't done merge sort yet, have we?
I'm sorry, what?
Merge sort. Have you done merge sort?
Merge sort? No.
No. So there's a lot of types of sorts. There's merge sort, selection sort, quick sort, heap sort, radix sort. So it's all right. We started with the first one, but this is not efficient. Okay. Double sort
Okay.
is the most basic one. So why is it not efficient? The answer for that is because this will keep, comparing, even though the whole list could be sorted, all right? Even in the first go, like the first attempt or the first pass which you make, maybe the list is already sorted, right?
Mm-hmm.
So then it's a waste of time to check each and every element if the whole array is already sorted. And it will always, even if the array is sorted, it will make one last pass to check. Because what is the criteria? The criteria to end, if you see here, it will end. Oh, this one is not efficient. There is no condition here.
Yeah.
Can you see this one? Uh, this has no condition. It's using 2 for loops. Okay.
Yeah.
So it will definitely check the whole. It will complete the whole, cycle. A total of 19 times. Okay. Because there are 19 elements, it will run from 1 the item. Okay. It will keep running 1 to 19. Does that make sense? This.
Yes. Yes.
So that's not efficient. It should run until some condition is met. The end condition was either this
To reach
what do you say?
0.
It reaches 0, which is the what is it called? Number items. Number items reaches 0, right?
Mm-hmm.
That's the first condition. Or the second condition was that no swaps. Swap equals 0, right? If there
Okay.
were no swaps, then it has to end. But there is no condition checking here, so this is inefficient. So the answer would be the algorithm continues even after, even if the list is sorted.
Just-
Yes, that's it. Now you can say instead of algorithm, you can say the iteration.
Okay.
Okay, explain how you could improve the efficiency. Yes, how would you improve it?
We'll add conditions to stuff as well, like we did. Yeah, that's the main thing, right?
Add a
Or
condition. Okay. Okay. 3
because I
marks.
know how we would check beforehand if it is already sorted.
Okay. So we have to run it at least once to know
Yeah.
it, right? But to know it, we can see if there is a swap. If there are no swaps, that means it's already sorted, right?
Yeah.
This means sorted. So we need to run it at least once. But to check this swap thing, we need a flag because this is a flag, right? It's not a variable, it's a flag. Flags can only be 0 or 1.
Yeah.
Okay. Boolean flag. Okay. So we need a flag. And the answer for this would be something like this. Read. So use of a flag to indicate if any swaps have taken place. If the inner loop has made all comparisons with no changes, comparison checks the flag at the end of each inner loop. If sorted, it breaks and stops.
Oh, okay.
So basically, what happens if the flag is 0, right? And then first you need a flag. So if needing a flag is 1 mark, then saying what you do with the flag is 1 more mark, and then to break it is 1 mark. That's it.
Got it.
Okay. Accordingly to 0. A comparison checks the flag value. It's 0 at the end. If it is sorted, it breaks out of the loop. That's it.
Okay.
That's your 3 marks. Okay, moving onwards. There's one more question on this. Okay, insertion sort, we haven't done that yet, have we?
No.
So we'll do that in a bit. This is after that, so we'll skip it for now.
Okay.
Let's try and implement bubble sort in Python. Okay, we'll also be looking at other sorting algorithms. There's a lot of content to cover, right? But we'll do it one step at a time.
Okay.
Now, let's see. Okay, I have to open. IDLE for you. 1 second. It's quite basic. Let's see. Get it open.
In Python.
Okay, so we're going to continue with the implementation of the bubble sort in Python, this part. Can you see VS Code on the screen?
Yes.
Perfect. All right, so let's make a function. It's going to take an array. Okay. Now we first need to also find the length of the array. Wait, that was too quick. Ignore the Copilot suggestions. So first we do this. Okay. Length. We check. We have the length, right? Then we need 2 for loops. Okay. So we repeat. Okay, we repeat from I to range n, basically from the start till end. Now this is not correct. Okay, this is just the suggestion by Copilot. Let's see what it says. Right, it is correct, kind of. So you loop it right from I to n. Then in the inner loop, you will run it from 0 to n minus 1 minus 1. N minus I minus what is this? Can you explain to me? What is
N
it trying
minus
to do?
minus 1. If it was n minus 1, I would
Was it n
okay,
minus
yeah. So
I?
I is the complete range of n, right? Yeah, so it's basically n minus 1 just in different term.
Not really. So it is like I will show you this afterwards, okay? Again, but for now, let's just keep it like this for now. I will tell you why it is like that. Now you remember from the whiteboard, right? That we sorted through. We don't run the for loop till the maximum n. In this case, we do, okay? Because in Python, when you write in the for loop, it doesn't work like this, right? 1 to n.
Yeah.
If you write 20 here, it will only run till 19. 20 is the stop, right? So we're going to put 20 for now, the number of items as it is, n, okay? If I put n minus 1, it would run, let's say the length is 20, okay? The length is 20. then n minus 1 would be 19. But if I put 19 there, it's not going to run till 19. It's going to run from 0 to 18. That's why I must put 20k as the length, as the maximum position. It will run one less than this. That's how Python works, right?
Oh, okay.
Okay. Now let's run the rest of it. So for j, some other j, okay, in range. Now before we run any of this, what else do we need? Let's see. We need the we don't need anything actually. We just have to loop it. We need the temporary variable, which
Yeah.
we will declare later. Let's start. Okay.
Okay.
Now, so it would be from 0 again till n. Okay. And then we check if the array at position j is greater than j plus 1, then okay, by the way, this is swapping in one line, but
Oh,
let's change that, make it a bit more basic. You take in the temporary position, you would take j, right? And then you swap j, and then you swap j plus 1. Okay, that's what we did. Now, after this, what do we do? That's, I think, done. Is there anything left here? Yes, we need to decrease n, right?
yeah.
So n minus minus. Yes. And then we return the array. That's it. After the whole thing is done. Okay. Now let's try and use this.
But this doesn't have a condition, right? So it won't end.
It won't end, not yet. Okay. So we'll improve
Okay.
it. We sort the thing first, bubble sort. Okay. Then we print it.
Mhm.
Sorted array is the array. Array. Yes, array. Okay. Let's run it. Okay, so there's a error, right? Let's see what the error is. Index out of range. Okay, the index is out of range because what are we trying to do? We're trying to run it j plus 1, right?
Yeah.
So that would be a problem. Because why would that be a problem? Run from 0 to 19, 20, 19. Yes, so this should be n minus 1, okay?
Okay.
Because obviously we have to go one less in the first loop. If you see here, this one. The number of items, the maximum position is 20, right? We run it to 20 minus 1. Because otherwise, as you know, we can only run it till here. If you go next, as in here, then you can't do the swap, right? There's
Yeah.
nothing there. It would give a out of index error. Okay, then let's try it. Okay, can you see it?
Yeah.
So the sorted array is 11, 12, 22, 25, 34, 64, 90. That's correct. Okay, that's the correct answer. Now, but let's see how many times it runs, all right? How many times it would run. So every time let's print. iteration. Okay, let's just print it inside. Now run it. The total iterations, as you can see, are a lot. Even if I, let's say, sort the whole thing, take the sorted one, replace it here. Let's run it. Again, even though the whole array is already sorted, right?
Yeah.
It took the same number of iterations when it was not sorted.
Mm-hmm.
That's not efficient. Now, what do we need? We need a flag. Flag, right? So where do we put the flag? We put the flag here. Start a swap equals to 0, right? And then we break. We check if then break, right? Or else
Mm-hmm.
if, again, there's another thing. Else we check if the n is equal to 0. Then we break. That's it. Okay? Any
Okay.
questions?
No.
That's it. Yes. So let's see. Swap is equal to 0. This is in the outer loop. And we did not set the swap flag, right? So you need to set it here. Swap is equal to
Oh.
1. Okay?
Okay.
So now we know there's a swap happening. And we need to reset the swap flag as well, right? Because if it's set once, then it doesn't reset. Again, like the next time it would say there's a swap, even though there was no swap, right? So we need to reset it here. Swap is equal to 0. Okay?
Oh. Okay.
We reset it and let's see. Run it. So it took these many iterations and it's done. 11, 12, 22, 25, 34. Okay, now let's use a sorted array, which is already sorted. Run it. It did not take that many iterations. It only checked once, right? So it checked from 6 times. There are 7 items, right? Yeah, checked 6 times, basically. N minus 1 times. Got it?
Got
There are
it.
7 items, so it checked 6 times, and then that's one complete pass, right?
Uh-huh.
And then it stopped because it was already sorted. There were no swaps. Fine?
Okay. Okay.
That's your whole WebAssembly done. Let's take the code. Okay. Okay. First, let's just put the code. Any questions in this code?
No, I mean, I'll first of all like go through it and then try to write it myself, and then I'll let you know if I have any
Okay.
questions.
Fine. Now, in this there was this part, right? Should I explain what this? Why was it like
Yeah.
this? Okay. So what they're doing here is you reduce it by 1 every time, right?
Uh-huh.
By 1. So we can just check directly, as in the first time you reduce by 1, the second time you reduce by 2, the third time it would be 3. In a sense, if you reduce by 1 every time, okay,
Yeah.
it would decrease like this, right? It would be 19, and then it would be 19, 18, 17, and so on.
Yeah.
But technically, as in the beginning it was 20, so this is I and this is J. J was 0, 1, 2, 3, right? I was 0, 1, 2, 3, and J was also 0, 1, 2, 3, let's say, going onwards. We don't care about J actually. What we do care about is I, right? Because we want
Okay.
to see this goes till where. This 0, 1, 2, 3 will definitely go to 19, or yeah, till 19, 1 less than 20. Now this J doesn't have to go till 19, it will reduce every time. Every pass, it would decrease, right? It would go
Okay.
first till 19, Then since 19 is done, it would go till 18, right? Then till 17, each pass, right?
Yeah.
So you can make a combination now. So when I is 0, it would go till 19 when I was 0, right?
Okay.
But when I was 1, it's going till 18 only.
Oh,
And then when
okay.
I is 2, it's going till 17. So technically all that's happening is n minus I minus 1. N is 20, I is 0 minus 1, which is till 19, right?
Mm-hmm.
Now, if I do 20 minus 1, that's 18, isn't it?
Yeah.
And 20 minus 2 minus 1 is 17, this. So you don't need to decrement it at the end. You could just decrement it in the loop.
Yeah.
Does that make sense?
Yeah.
So yeah, so the AI, the Copilot just made it more efficient. But we're trying something basic right now. But yes, as a programmer, your job is to make the code more short and concise. That's the whole goal. Because if you take part in competitions, in
Mm-hmm.
hackathons and stuff like that, time complexity is a big deal, right? Someone can run a code which takes 5 seconds, the other guy can do it in 1 second. The other guy will obviously win. Okay, so that's basically it. That's the logic of making it more concise. Now there was one more thing. How to swap it in one line. Are you interested
Yeah.
in this?
Yeah. Yes.
Okay, so this one. Now we're swapping it using a temporary variable, right?
Mhm.
But do we need a temporary variable? That's the question. Okay, let's see. We have array j, right, and j plus 1. So what you're technically doing is you're swapping both of them, as in you're placing the values simultaneously. Okay, so Python
Yeah.
would automatically create sort of like a temporary memory location for you. You don't have to do it. So when you do this, okay, Python automatically swaps the elements for you. Okay, so let's
Oh.
say
Oh.
there is array j, so j plus 1 goes here and j goes here, all right?
Okay. Yeah, that's understood.
So
Yeah.
basically it takes both of these values into two temporary locations, 10,
Mm-hmm.
9, and then simultaneously it puts them into the required locations. Fine.
Oh, okay. Okay.
But if you do it one at a time, then as you saw, everything would become 9 or everything would become 10, right? So you
Yeah.
can't sort it. But here what they're doing is it's automatically taking some temporary locations and then simultaneously changing them. So that's another way you can swap with Fighters.
Oh,
Here,
okay.
alternate way, not without. Now, some of the interviews, when you go for a job interview, they may ask you, how can you swap without using a temporary variable? Such a thing will not really work in Java, but it is possible in Python like this, right? If they ask you, you know what
This
to
is like
answer.
easy enough to understand that. Yeah. Yeah.
Yeah. Now, the next thing, uh, we have file handling
Yeah.
and the abstract data types. Okay, so we're going to do file handling later, but
Okay.
first we're going to look at the other data types as we planned in the beginning, okay? File handling is like a separate topic in itself. It
Mhm.
doesn't have much to do with data types. So we'll look at file handling after this. Let's first look at the other data types which we have, other data structures, okay? Now we're looking at abstract data types. These abstract data types are things which we create as programmers to suit certain requirements of different problems. Okay. Now, what you will be studying are stacks, queues, and linked lists. Fine.
Okay.
Okay. So we need to see how to implement them, how to edit them, and how to basically delete some stuff in there as well. Okay. Uh, First one, stack. What is a stack? Stack is basically a pile of items, which is like a pyramid, one on top of the other. Okay.
Mm-hmm.
Now, there's something called first in, first out. There's something like that. Then there is first in. There's first in, first out. Then there's first in, no, last in, first out. Last in, first out. LIFO and FIFO. These are two types of, let's say, strategies or approaches we have in these data types. Okay. Now the stack. Okay. Read this part. When an element is popped, removed from the stack, the top of the stack pointer will decrease to the element now at the top of the stack. Okay. So basically, in a stack, when you put the items in, all right, the last item you put in is going to be the first item you take out.
Got it.
Okay. This is LIFO, LIFO, last in, first out. Okay, no need to write it. I hope you get it. Okay.
Yeah.
So D would be removed first, and then C, then B, then A. Moving onwards. Now, how do you declare the stack? You declare it like this. Right. Let's take it here. This is important. Pay attention to the naming schemes or the pseudocode pattern. Okay, moving onwards. Now, the queues. In the queue, it's actually kind of different. It's first in, first out. Okay, the guy who went in first will also leave first.
Okay.
So you go in like this, you come out like this. This was kind of different. You go in like this, and then you come out from there as well, right? The other end was blocked, but this is not how it is. Here, you go in and you come out. So A went in first, but it would also come out first. Got it?
Okay.
So you put the guy, whoever was the first one to enter would be the first one to exit as well. Okay. Now yes, we need a pointer. Okay. So in these, to implement these things, we in Python actually, what we do is use a list, and then we create this abstract data type because it's abstract. It's something you're creating. Okay.
Okay.
For your own use case. Now, this is what you need, by the way, these 5 operations, right? Note what you need to do. Okay. Now you need a pointer, the end of the queue pointer and the start of queue pointer, end of stack pointer and start of stack pointer, top or base. Yeah. Now, done. Any questions in this?
No.
Okay, fine. What we need to see is how to implement these 5 things in each of them, all right? Not a lot of information is given here, it's just the basics. So I'll tell you the information myself on the whiteboard. But first, look at this, the linked list, okay? What's happening in this? So we know, okay, what is a queue? It's FIFO. A stack is LIFO. Now, the linked list, what is this? It's like a train, basically, or a chain.
Okay.
You have nodes, you have null pointers, start pointer, okay? And that's it. These are 3 things are needed. So the start pointer starts your node, your linked list. Each node has 2 things, the data item, okay, and the pointer. Each pointer points to the next node, okay? And this pointer points to the next node, and so on. Now,
Okay.
the end pointer, this is the end pointer. It is a null pointer. Fine?
Okay.
No, there's nothing there. Okay, fine. Now we need to put some value here and declare it as a null pointer. We'll do some condition checking. Okay, so moving onwards, you can see first thing, how do you add a node here? So what I can do is, as I know each pointer points to the next node, right?
Yeah.
What I can do is, instead of just this pointer pointing to D or B pointing to D, I can add another node here, which is called C. Then this guy points to C, and then C points to D. Okay, and I will
Okay.
remove this connection, direct connection. So technically now I added a node in the middle of the list. Does that make sense?
Yeah, that's it.
Okay, easy, fine. Now if you want to delete something, for example, you don't want L, so I would just make this directly null pointer, and this connection would be gone. So L is now kind of deleted.
Got
Okay.
it.
If you want to delete, let's say, something else, let's see, yeah, you don't want B, right? There is this connection going, and then from B to D. But if you want to bypass B and remove it technically, you can remove these connections and directly go from the start pointer to D. Fine?
Oh,
Okay?
okay.
Any questions?
No.
Or directly go from D to P, and then L is gone, deleted.
Oh,
Okay. Now, that's about it. Deleting, adding, done. There are a few basic things you need to understand how this happens. Okay, the node has to be copied, the pointer has to be copied. I'm just giving you a general visualization of it first. Then let's see how to do it using code. Did you understand how the thing worked? Was that clear? As in, let's see, to add a node, you basically add an extra node, and then B would point to C and C would point to D, right?
yeah.
That was adding a node. Then to delete a node, instead of pointing from D to L to F, you directly point D to P, as in there's D to L to P, right? Instead of doing this, DLP, you directly go from D to P. So therefore, L is deleted. Okay, that's about it. Now, how do we implement all of that using Python code and pseudocode? I have to teach you that, because a lot of information is not here, and
Okay.
that's kind of not good, because in the exam they won't ask you these things. They will just directly ask you the code. This is what they will ask you. Okay.
But I think in the last paper there was some like diagram I had to complete in the linked list.
Yeah, you need a. There will be diagrams, obviously, but that's easy. I mean, it's easy compared to if other things if you have practice, right?
Yeah.
We will do parts of the questions. Now the code, you also have to write the code for each of them. So basically, write the pseudocode to remove a node. Okay. Or there is a linked list, and now let's say Sam wants to add some other information. Add that and implement the pseudocode for it. So you need to know how to do that, and not just for linked list, but for each of them. Okay, so I think we'll look at those in the next class. But for now,
Okay.
I'll just put these and give you some homework.
Yeah.
There is another book actually, I think, which is better. We'll try using that one for the next class, which has more
The other one
information, more code.
was it that 9608?
No, it's also 9618, but this is by Cambridge. That one is by Hodder. That's also for Cambridge, but they're different like publications. There's one by
Oh,
Oxford as well, right? That's the only difference.
oh, okay.
This book has limited information. It's more visual. That's good, but we, as a computer scientist, I'd like to see things written as programmings, right? Okay. Regardless, we'll try to do creating the instance or declaring the data type first, and then finding an item, inserting an item, deleting an item, and printing or accessing the items. These are four things you need to do. I'll do it
Okay.
in the next task. Now, for this one, okay, your homework is basically try to Google it or read the book, and try to implement a stack in Python and add and do the following. Add an item, pop an item, or basically remove an item.
Yeah.
That's it.
Okay.
Okay. These are two things you need to do in a stack. If you can, try find an item. That's it.
As in find, like you mean I'll give it an item and it will tell me what position it is in the index.
Yes. Yes. Where
Oh.
it is, if it is there, and if it is there, if it is present, which location is it at? Okay.
Oh, okay. Got it.
That's it. Now, in a stack, usually we don't care about the position. You can find the pointer because it's all about pointers, right?
Yeah.
So it's more about finding if the item is present or not. Okay. But you can also print the position. Yeah, for sure. Try it. Okay.
Yeah.
So I need the position, if position, and whether it is. That's all for today then. I will see you in the next class. Do the homework and send me the link. Take care.
Oh,
Goodbye.
thank you. Bye.